6.3 is going to continue our ideas of solving quadratics, and in 6.2 we did graphing solutions, and graphing solutions are great when that solution is exactly 4, 0, negative 2, 0, something that crosses that axis at an exact point. But graphing takes time and it's not always exact. So now we are going to go back to talk about how to solve these by factoring. How can we do it algebraically so that we have an exact answer? So a couple of things that we need to just quick review. We need to review with our solving something called the zero product property. And what that property says is that if I have A times B and it equals 0, then A has to be 0 or B has to be 0. And if you think about how numbers work, 0 times anything is 0. So if either one of these two values is 0, it doesn't matter what the remaining one is. The product will be 0. So we are going to be using this idea for our solving. Now we're going to be factoring, because remember, factoring is going to take a number like this, which that doesn't factor, and it's going to turn it into two quantities that are going to look a whole lot like an A and a B. And then we're going to say that this thing could equal 0 or this quantity could equal 0, and we're going to solve these two little baby simple problems. Now remember, the other key piece here is whatever your power is. If I have an x squared thing, then I have up to 2 solutions. I could have 0, I could have 1, I could have 2. And we've talked about that already. If I have an x cubed thing, then I could have up to 3 solutions. So that exponent tells you how many potential solutions. Now some of them could be repeats, they could be imaginary numbers, but you have an idea how many you're looking for before you get started. So if you go back to the lesson, our steps. First step, get one side equal to 0. Always have the quadratic term x, the x squared term, positive. It's much easier to factor. So move everything left or right so your x squared is positive. Then we're going to factor, and we're going to use that zero product property to find the roots. So how does this work? So here's our first example. X squared equals negative 4x. So I'm going to go ahead and add 4x to both sides. I'm going to write it in descending order. Now, rule number 1 of factoring is we always look for greatest common factor, and then we look for our special factoring, our difference of perfect squares, our perfect cubes, and then we use our trial and error. And that's really kind of the gist of factoring. So when I look at this one, I clearly see I have greatest common factors, so I'm going to factor those out. And now I have one thing, two things being multiplied. So x equals 0 or x plus 4 equals 0. Well, this is an answer right here. Subtract 4 from both sides, x equals negative 4. And those are your two solutions. If we were to graph x squared equals negative 4x, that is where it would cross the x-axis. And so just out of curiosity and to show you, I'm going to pop up that graphing calculator. And type in x squared plus 4x, plus 4x and hit graph. And you will see it clearly crosses at negative 4 and 0. And so that is how our algebraic solutions and the graphing solutions are actually giving us the exact same answers. So continuing on, 3x squared equals 5x plus 2. So we need to get equal to 0, so I'm going to subtract 5x and subtract 2. If you're worried, do this in multiple steps, that's fine. So 3x squared minus 5x minus 2 equals 0. Those signs are everything. Now I'm going to go ahead. There's no greatest common factor. Now I'm going to think about what factors of 3 and 2 under plus minus are going to combine to make really subtract. So these are my first, these are my last, outside minus inside. And what I see is if I take 3 times 2 and I subtract 1 times 1, I'll get 5. Now I want my 5 to be negative, so if I put my 2 there and my 3 there, leaves a 1 and 1. Outside term, minus 6x. Inside term, 1x, that gives me minus 5x. Quick check of your first two, 3x squared, last two, minus 2. So what do I have here? I have 3x plus 1 times x minus 2 equals 0. If I apply the zero product property, I have 3x plus 1 equals 0, or I have x minus 2 equals 0. Solve each baby problem separate, subtract 1, 3x equals negative 1, divide by 3, x is equal to negative 1/3. There's one solution, add 2 to both sides, x equals 2. And this is a great example that if we graphed this, we would have an approximate between 0 and negative 1 kind of answer. Algebraically, we get the exact answer. Now if we look at an example like x squared minus 6x equals negative 9, first we need to add 9 to both sides. Now we don't have a greatest common factor, so I'm going to go ahead and think about what factors of 9, if I have minus plus, that means I have 2 minus, are going to add together to make 6. Clearly 3 and 3. This is what's called a double root. Our answer shows up twice. It's really that binomial squared, that quantity squared pattern. So I only need to solve one of these. And that is my exact answer. Again, if we go back to the graphing calculator, and we type in our equation, which was 3x squared minus 5x minus 2, and we hit graph, I graphed the wrong one. Sorry, that was the last one. We can see we get our negative 1/3 and our positive 2. If we do the problem that we're on right now, x squared minus 6x plus 9, and we hit graph, you can see there is clearly just one solution. It only intersects in one spot. So that graphing is supporting our algebraic answers without taking as much time. So just a quick factoring question. What is the positive solution? When I look at this, the first thing I see is a greatest common factor. So I have 2 times x squared minus 4x minus 21 equals 0. Because there's no variable out here, I don't have to worry about that providing an answer. So I'm going to go ahead and think about factoring this part. I have minus minus, so that means I have one of each. Look at the factors of 21 and say, how could they subtract to make negative 4? They would obviously boil down this way. When I look at this factor and this factor, no variable, I don't have to consider it. X plus 3 equals 0, or x minus 7 equals 0. Subtract 3, add 7, and it's clear that 7 is my only positive answer. So now we're going to talk about building these things backwards. So write an equation, a quadratic equation, with negative 2 and 3 as its roots. Then write the equation as a quadratic. So let's really just start. What does that mean? From the back, our final answer would be x was equal to -2. Well, undoing and working backwards, we would add 2 to both sides, and we would end up with x plus 2 equals 0. This gives me one of those pieces. If I ended up with x equals 3 and I subtract 3 from both sides, x minus 3 equals 0, this is also one of my starting points. There are my two quantities, x plus 2 times x minus 3 equals 0. Go ahead and FOIL it. X squared minus 3x plus 2x minus 6 equals 0. Combine like terms, and you now have a quadratic equation that these are the roots, and you know they are the roots because you built it that way. So we basically took our solving process, where here we would factor, and we worked it backward. So what does it look like if I have something scary like -2/3 and 6? Well, our process is going to be exactly the same, so that means we ended up with x is equal to -2/3 and x is equal to 6 as our final answers. So we're going to add 2/3 to both sides, and so we have x plus 2, start over, we're not going to do it that way. What we would do first is we would multiply both sides by 3 to get rid of that fraction. So I'd have 3x is equal to -2. Then we would add 2 to both sides. We'd end up with 3x plus 2 equals 0. Now adding 2/3 to both sides would work, but we don't usually deal with quadratics with fractions in them. We get the fractions as answers. So we want to undo that division and then the subtraction to work it backwards to get that quantity. Here we would just subtract 6. So x minus 6 equals 0. Now I'm going to go ahead and multiply my two quantities. So I have 3x plus 2 times x minus 6. Do the quadratic or the foiling. 3x squared minus 18x plus 2x minus 12 equals 0. Combine like terms, 3x squared minus 16x minus 12. And that is your final answer when you are all done factoring and foiling out your answers. Good luck on your homework.